Hello there, and welcome to Sleepy Science Vault. Have you ever looked up at the sky and simply wondered why it is blue? Tonight, we are going to explore that question together. Slowly, gently, with no rush at all. Let yourself get comfortable. Let your body feel heavy and warm. And just listen. The first thing to understand is sunlight itself. When sunlight leaves the sun and travels toward us, it is not yellow or gold. It is actually white. Sunlight is white light. It contains all the colors of the rainbow, woven together, all at once, in perfect, quiet balance. Now, light is a kind of wave, like ripples moving slowly across a still pond. Different colors of light have different wavelengths. Some wavelengths are long, slow, and wide. Others are short, and tight, and small. Red light has a long, gentle wavelength. Blue light has a shorter, quicker one. All of these colors, all of these wavelengths, travel together from the sun toward us in perfect silence. When that light reaches the earth, it has to pass through something. Our atmosphere. That great, soft, invisible blanket of air that wraps around our planet and holds everything safe. Inside that atmosphere are tiny, tiny particles, mostly molecules of oxygen and nitrogen. These two gases make up almost everything we breathe, almost everything around you right now. As you lie here in the quiet, when light from the sun hits these tiny molecules, something remarkable happens. The molecules don't simply let the light pass by. They absorb it, just for a moment. And then, they send it back out again, in a new direction. Scattered, like a gentle ripple moving outward. The molecule almost behaves like a tiny antenna, receiving a signal and broadcasting it again, in all directions. Now, here is the part that matters. Not all wavelengths of light are scattered equally. Shorter wavelengths, like blue light, are scattered far more than longer ones. Far more than red, or orange, or yellow. Blue light bounces, and scatters, and spreads in every direction, all across the sky, while the other colors pass through more easily, continuing on their way. This process has a name. A beautiful, unhurried name. It is called Rayleigh scattering, named after a scientist called Lord Rayleigh, who described this effect more than a century ago. Rayleigh scattering depends on something very specific. It depends on size. The particles doing the scattering have to be much smaller than the wavelength of light itself. The molecules of oxygen and nitrogen are exactly that small. Perfectly, quietly, small enough to scatter blue light so completely that it fills the entire sky above us. And the mathematics behind it is surprisingly elegant. The amount of scattering a wavelength experiences follows what is known as a 1 over lambda to the 4th law. What that means, in simple terms, is that even a small change in wavelength makes an enormous difference in how much it scatters. Blue light, with its short wavelength, scatters not just a little more than red light, but roughly 5 to 10 times more. 5 to 10 times more. Just because its wavelength is slightly shorter. Isn't that something? Now, all the colors in sunlight are scattered. To some degree. Red is scattered, orange is scattered. Even green is scattered, a little. But blue is scattered so much more than the others that it floods the sky in every direction. And when we look up, our eyes receive more blue light than anything else. So the sky appears blue. It is not paint. It is not a reflection of the ocean. It is simply light dancing off invisible particles across the entire dome of the sky above you. 100 miles of atmosphere, quietly turning sunlight into something beautiful. Let that image settle over you, like something soft. You are lying beneath 100 miles of gentle air, full of tiny invisible molecules, each one catching the light and sending blue, drifting in every direction. There is nothing you need to do. Nothing to figure out. Just breathe and rest and let the blue sky exist quietly above you. You have been resting here for a little while now, letting your breath slow down, letting your thoughts drift. And we are going to keep going together. Gently. There is no hurry here. Just a quiet voice and a quiet sky. We talked about Rayleigh scattering, about how blue light bounces off tiny molecules of air and fills the sky in every direction. But there is more to this story. Something even more interesting, hidden just beneath the surface. You see, Rayleigh scattering does not treat colors simply as blue or red. It responds to wavelength. And the shorter the wavelength, the more that light gets scattered. We said blue has a short wavelength, and that is true. But there is a color with an even shorter wavelength than blue. That color is violet. Violet light sits at the very edge of what our eyes can see. It is scattered even more than blue light. Even more strongly. Even more completely. Across the whole sky. So here's the question that should be forming very slowly in your mind. If violet is scattered more than blue, why does the sky look blue and not violet? Let that question sit with you for a moment. The answer, as it turns out, has almost nothing to do with the sky, and almost everything to do with you. Your eyes. Those quiet instruments you use every waking moment are not equally sensitive to all colors. They are tuned, carefully, beautifully tuned, to certain wavelengths more than others. Inside your eyes, there are tiny receptors called cones. And there are 3 kinds of cones, each one sensitive to a different range of color. One type responds most to red light, one to green, and one to what we call blue. But here is the thing. That third cone, the one we call blue, is actually most sensitive to wavelengths that sit between blue and green, closer to a pure sky blue, then to the deep violet end of the spectrum. Violet light sits in a region where your cones are much less responsive. Your eyes simply do not register violet as strongly as they register blue. So even though violet is being scattered just as furiously, maybe even more furiously, across the sky, your eyes receive it quietly, almost gently, as if it were barely there. And blue, that slightly longer, slightly calmer wavelength, lands right in the sweet spot of your color vision. Your eyes are waiting for it, ready for it, and they receive it clearly, fully. The sky is blue, not just because of what light does, but because of how you see. Isn't that something to hold gently in your mind? The color of the sky is partly inside you. It lives in your eyes, as much as in the air. Let that settle. Now, there is another piece of this that is quietly wonderful. We said that Rayleigh scattering depends on the size of particles. The molecules of oxygen and nitrogen are very, very small. Smaller, by far, than the wavelengths of visible light. This is not a coincidence that works against us. It is the exact condition that creates the blue sky. If the molecules were bigger, the scattering would work differently. It would not favor blue. It would not favor any particular color at all. The sky might look white, or gray, or something we have no name for. But because air molecules are so exquisitely, perfectly small, they scatter light in precisely the way Rayleigh described. Wavelength by wavelength. Shortest scattered most. The smallness of air is what gives the sky its color. Think about that for a moment. The sky is blue because the air is made of things you cannot see. Things smaller than a wave of light. Invisible, unimaginably tiny. And yet, their effect is vast. Stretching from horizon to horizon. From sunrise to sunset. Now, here's another thought to carry you gently towards sleep. When you look up at the blue sky on a clear afternoon, the light reaching your eyes has not traveled a simple path. It has not come straight from the sun to you. It has been scattered, redirected. Twice. Sunlight enters the atmosphere, and a blue photon, a tiny packet of blue light, bounces off one molecule, and then bounces again off another, and then perhaps again, before it finally, quietly, finds its way to your waiting eye. The blue you see is not direct sunlight. It is scattered sunlight. Sunlight that has been gently redirected across the whole cathedral of the atmosphere, arriving at you from every angle, from above, from the sides, from nearly everywhere. That is why the sky looks blue in all directions on a clear day. Not just where the sun is, but everywhere you look. Up, sideways, near the horizon. Blue everywhere. Because the scattering sends light in every direction. not just forward. Let yourself imagine that for a moment. You are sitting at the bottom of something vast and glowing. And from every angle above you, blue light is gently raining down. Each photon having bounced and drifted its way toward you. From somewhere high above. It is not a harsh or bright image. It is soft. It is diffuse. It is like being held inside something luminous. And very, very calm. Now, some people wonder, looking out at the ocean, or at a lake on a still afternoon, whether the sky is blue because the water is blue, or whether the water reflects the sky. And the answer is a gentle one. The sky does not borrow its blue from the ground. It does not reflect the ocean. It does not mirror anything below it. The sky's blue is its own, made entirely up above you, by light and air and the quiet physics of scattering. No mirror, no reflection, no borrowed color. Oceans can look blue partly because they reflect the sky, and partly because water absorbs other wavelengths. But the sky itself, that deep quiet blue directly above you on a clear day, exists completely independently of anything on the ground. It is a free effect. It requires no surface, no reflection, no help from below, just air and light and physics. And in a way, that makes it feel even more remarkable. This color that stretches over everything, over cities and forests and deserts and oceans. The same color everywhere on Earth, under the same clear conditions. Every person who has ever lived beneath an open sky has looked up at the same color, made by the same invisible process. Your great-grandparents looked up at that blue. Children on the other side of the world are looking at it now. Explorers centuries ago tilted their heads back and saw exactly what you see. The blue sky is one of the most shared experiences in all of human history. Let that feel warm. Let that feel like something comforting. You are part of something very old, and very wide, and very quiet. The sky does not demand anything of you. It asks nothing. It simply scatters its blue light in every direction, for anyone who happens to look. And tonight, you do not even need to look. You can simply know it is there. Above the roof. Above the clouds if there are any. Above everything. Quietly blue. Quietly doing what it has always done. Let your eyes grow heavy. Let your breath come slow. Let the thought of all that soft blue light, somewhere above you in the dark, carry you gently further into rest. You are still here, still resting, still breathing slowly, and that is all you need to be doing. The world outside is quiet, and we are going to stay here together, in this soft, unhurried place, for a little while longer. We have been talking about the blue sky, about light and air and the invisible physics that paints the world above us every single day. And there is still more to discover. Gentle things, quiet things, Things that will give you something soft to rest your mind on. As you drift, we said that the blue you see when you look up is not light that came directly from the sun. It is redirected light. Light that was heading somewhere else entirely, and was gently, quietly, turned by a molecule too small to see, and sent toward you instead. Think about that for a moment. Every photon of blue light that has ever reached your eyes from the sky was on a different journey before it found you. It was not meant for you. And yet, there it was, arriving quietly from above. There is something almost tender about that. Now, the blue of the sky is not a bright or piercing thing. Not really. If you could somehow measure it, the intensity of scattered blue light in the sky is actually quite faint compared to direct sunlight. A single molecule scattering a single photon produces almost no light at all. Something unmeasurably small, impossibly dim. And yet, you can see the blue sky clearly from anywhere on Earth, on any clear day. How? Because what the sky lacks in intensity, it more than makes up for in scale. There are not dozens of molecules scattering light above you, or thousands, or even millions. There are trillions, upon trillions, upon trillions. Every cubic centimeter of air above you contains roughly 27 billion molecules, each one a tiny, silent, invisible scatterer, each one doing its small part. And together, all of those trillions of tiny quiet events add up to something you can see from 100 miles away. Something vast and soft and blue. The sky is not the work of one thing. It is the work of everything. Every molecule, every scattered photon, every redirected ray of light, contributing one invisible thread to something enormous. Let that image settle over you, like something warm. A trillion quiet things working together to make one beautiful color that you have looked at your whole life. Now, there is something else worth knowing. Something that might surprise you. The sky is not pure blue. If you were to look at the color of a clear sky and compare it to what a physicist would call a pure blue, you would notice a difference. The sky tends to sit slightly on the cooler, paler side. It leans toward what artists might call a blue-white, rather than a deep saturated blue. This is because the scattering does not select only blue. All colors are scattered to some degree. Red, orange, yellow, green. They scatter less than blue. But they are still there. Still present. Still softening the color. Mixing into the blue like a whisper. The result is not a single pure hue. It is a blend. A gentle, luminous blend that we simply call blue. Because blue is the part that wins. And honestly, that impurity is part of what makes it beautiful. A perfectly pure blue sky might feel cold, clinical. But the real sky, with all its mixed and scattered light, feels alive. It breathes. It shifts. And speaking of shifting, the sky is never truly solid. We sometimes speak of the sky as if it were a flat painted thing, a backdrop behind the world. But it is not flat at all. It is a dome, a vast curving volume of air, stretching in every direction. And the color it shows you is not the same everywhere you look. If you were lying down right now, looking straight up, you would see the deepest blue, the purest part of the sky, right there at the top, directly above you. But if you slowly turned your gaze toward the horizon, the blue would gradually, gently, fade. It would lighten, soften, and near the horizon it would become almost pale, almost white. This is the dome effect. This is the sky's quiet gradient. When you look straight up, you are looking through the thinnest part of the atmosphere, the shortest path through all that air. And the blue scattering is concentrated, clean, and deep. But when you look toward the horizon, you are looking through a much longer stretch of atmosphere. Light traveling at that angle has passed through far more air, encountered far more molecules. And not just blue light has been scattered now. Other colors have had their chance too. The blue has been spread so widely, so many times, that it begins to dilute. And the sky near the horizon turns pale, almost milky. So the sky is not one color. It is a gradient, a slow, seamless, breathing gradient, from deep blue above your head to pale soft white at the edges of the world. Let yourself picture that for a moment. Even with your eyes closed, you know what that looks like. You have seen it 1,000 times. That long arc of fading blue, from the top of the sky, all the way down to where the world begins. It is one of the most familiar sights in all of human experience. And yet very few people stop to really look at it, to notice the gradient, to follow the color as it softens. Tonight, in your mind, you can look at it as long as you like. Now, the sky also changes throughout the day. Not just at sunrise and sunset, which we will talk about another time, but even in the middle of a clear blue day. The quality of the blue shifts. The sky is at its bluest around local noon, when the sun is as high as it will go, directly above, or close to it. The atmosphere is at its most transparent. The path of sunlight through the air is at its shortest, and the scattering is at its most efficient, its most pure. The blue at noon is as deep and clean as the sky ever gets. There is something very still about noon light, something almost suspended, as if the whole day is holding its breath. Before noon and after noon, the sun sits at an angle, and its light travels a slightly longer path through the atmosphere. The blue is still there, of course, but it is a little softer, a little more blended with other scattered light. And there is one more beautiful detail to add to all of this. The sky is not equally blue in every direction at the same time. There is a specific point in the sky that is always the bluest. and that point is at a right angle to the sun, 90 degrees away from wherever the sun happens to be. If the sun is to your right, the bluest part of the sky is directly above you. If the sun is low on the horizon, the deepest blue arcs high overhead, always keeping that 90-degree distance, always staying as far from the direct sunlight as possible. Photographers know this. They know that if you want to capture the deepest possible blue sky in a photograph, you turn 90 degrees away from the sun and point your camera there. And the reason is simply that at that angle, you are looking at the part of the sky where Rayleigh scattering is most efficient, where the geometry of light and air combines perfectly to give you the purest, deepest, most concentrated blue. It is a quiet kind of perfection. Not dramatic, not loud, just precise. The universe arranging itself into something beautiful at exactly the right angle. All of this, the gradient from above to the horizon, the deepest blue at noon, the perfect blue at 90 degrees. All of it is simply light, doing what light does, following the rules it has always followed. And you have been looking at the result of those rules every day of your life, without knowing all of this was underneath it. Now you know. And somehow, knowing makes it feel more restful, not less. Because the sky is not random. It is not chaotic. It follows something orderly, and gentle, and consistent. Every clear day, the same gradient. Every noon, the deepest blue. Every 90 degrees, the purest hue. There is comfort in that kind of order. Let yourself feel that comfort now. Let the thought of that wide blue dome, its soft gradient, its quiet precision, settle over you like something cool and calm. You are beneath all of that right now. Even in the dark. Even with your eyes closed. The sky is there, doing its quiet work, scattering its blue light, following its gentle rules, just as it always has. And you are here, warm, still, heavy, drifting slowly, further into rest, still here, still breathing, still resting. There is nowhere else to be right now. Nothing waiting for you. Nothing to remember or plan or solve. Just this voice, and this quiet, and the slow, gentle unfolding of something beautiful. We have been spending time with the sky, learning its secrets, one soft fact at a time, and there are still more waiting for us. Unhurried, peaceful things. Things that ask nothing of you, except to listen. Let your body sink a little deeper. Let your shoulders fall. Let your breath find its own slow rhythm. We talked about how the sky is bluest at 90 degrees from the sun. And there is a reason for that. A reason that goes a little deeper, and is worth resting your mind on. When sunlight travels through the atmosphere, it does not scatter equally in all directions. The scattering has a preference. A gentle, geometric preference. light that hits a molecule and scatters sideways, at a right angle to the direction it was traveling. Scatters more efficiently than light that continues mostly forward. This is called side-on scattering. And it is the reason that when you look at 90 degrees from the sun, you see the sky at its most concentrated blue. You are looking at the place where the scattering geometry is working at its best. It's most efficient. It's most pure. Now, along the actual path of the sun's rays, along the direction the light is traveling, the scattering is somewhat different. Light along that forward path scatters more weakly to the sides, and so the sky directly in line with the sun appears a little less intensely blue, a little more washed out, a little brighter, but softer. It is a subtle difference, the kind of thing you might not notice unless you were looking for it. But it is there. A quiet signature of the way light moves, written across the whole sky above you. And speaking of the way light moves, there is something about the sky that most people never think about. Something that is happening right now, above you, even as you rest. The blue light scattered by the sky is not ordinary light. Or rather, it is not random light. Sunlight, when it leaves the sun, vibrates in every direction at once. Up and down, side to side, every angle. All simultaneously. This kind of light is called unpolarized. But when that light hits a tiny air molecule and scatters, something changes. The scattered light no longer vibrates in every direction. It tends to vibrate in one direction. Aligned, ordered, organized. This is called polarization. And the sky, our quiet blue sky, is partially polarized light. The whole sky above you is filled with faintly polarized blue. A kind of hidden order, invisible to the naked eye, but real. Absolutely real. And here is the thing about invisible things. Just because you cannot see them does not mean they are not there. The polarization of the sky has always existed. Long before anyone knew what it was. Long before anyone had words for it. Bees can detect it. They use the polarization pattern of the sky to navigate, to find their way home. Even on partly cloudy days. Even when they cannot see the sun directly. The sky is a map for them. A polarized, glowing, blue map that only they can read. Let that image sit gently with you. Somewhere right now, in the dark, a bee is perhaps resting in its hive, having navigated home by reading the hidden pattern of the sky. Quiet and safe, just like you. Now, if you have ever worn polarized sunglasses, you have actually interacted with this effect. Whether you knew it or not. Polarized lenses are designed to block light vibrating in certain directions. They filter out specific orientations of light. When you put on polarized sunglasses and look at the sky, and then slowly tilt your head, the sky actually changes brightness. It dims, and then brightens again. as the angle of the lens changes relative to the polarization of the scattered light. The sky itself is not changing, but your window into it is rotating, filtering more or filtering less of the polarized blue. It is one of those rare moments where an invisible physical phenomenon becomes something you can feel, something you can watch with your own eyes, simply by tilting your head. Most people have done this without knowing what they were seeing. Just a strange brightening and dimming. A curious effect. Nothing more. But now you know what it was. The hidden order of the sky, revealing itself through a slow tilt of the head. Let that feel like a small and gentle gift. Something beautiful, discovered quietly. Now, there is another thing worth knowing about the sky and the sun, and the way they relate to each other. The sun looks yellow, or sometimes orange, on a clear day. And you might wonder if sunlight is actually white, if it contains all colors equally. Why does the sun itself look yellow? The answer is the same process we have been talking about all along. As sunlight passes through the atmosphere, blue light is scattered away from the direct beam. It is pulled sideways, in every direction, sent out into the wide sky, which means that the light arriving directly from the sun, the beam you would see if you looked toward it, has had its blue removed. A white light with its blue taken out is no longer white. It shifts toward yellow, toward orange, toward the warm end of the spectrum. The sun looks yellow because the sky is blue. They are two sides of the same effect. The sky receives the blue that the sun loses. The sun loses the blue that the sky receives. One effect, two colors, perfectly balanced. And here is the quiet part. The part that is almost too subtle to notice. When you look at the blue sky, you are not seeing blue light that was on its way to you anyway. You are seeing blue light that was on its way somewhere else. Blue light that was part of the sun's white beam and was redirected, scattered sideways toward your waiting eyes. And when you look toward the sun, you are seeing all the colors that weren't scattered, all the colors that made it through. Red, orange, yellow, arriving intact. The blue is simply absent from that beam. It left. It scattered away into the sky, long before the light reached you. You never see the missing blue in the sun's direct light, because it is no longer there to see. It has already become the sky. There is something almost poetic about that. The sky and the sun are not separate things. They are one light, divided. Part of it arrives directly, warm and yellow. Part of it takes the long way round, scattered in blue. And together, they make up almost everything you see when you step outside on a clear day. Now, there's one final thought for this part of our journey. A thought that requires you to leave the earth entirely. Just for a moment. In your imagination, imagine you are rising, slowly, quietly, up through the atmosphere, up past the clouds, up past the highest reaches of the air. As you rise, the sky around you slowly changes. The blue begins to deepen, and then darken. The atmosphere thins. There are fewer molecules to scatter the light, fewer tiny antennas doing their quiet work. And then you pass through the last thin layer of air. And suddenly, you are in space. The sky is no longer blue. It is black. A deep, infinite, velvety black. In every direction. And the sun looks different up here. Without the atmosphere filtering and scattering its blue light. Without any air to remove the shorter wavelengths from the beam. The sun appears slightly, subtly bluer. Not dramatically different. Not unrecognizable. But cooler. Closer to white. Closer to what sunlight truly is. Before the atmosphere puts its gentle hand on it and separates it into sky and sun, into blue and yellow, into scattered and direct. Astronauts have described the sun from space as brilliant and white, harsh and unfiltered, without the soft warm glow we see from the ground. The yellow sun we know and love is an atmospheric invention, a gift of scattering, as much as the blue sky is. All of it. The blue dome above you, the warm yellow disk in the daytime sky, the pale horizon, the deepest blue at 90 degrees. All of it is one light, passing through one atmosphere, and becoming everything. Let that feel like something complete, something whole. You have been carrying all of this gently in your mind, and now you can set it down. Let it rest beside you. The sky will be there tomorrow, doing all of these quiet things, whether you think about them or not. Scattering its blue, lending yellow to the sun, hiding its polarized order in plain sight. And you will be here, resting, breathing, warm and still and unhurried. Let your thoughts soften now. Let the facts dissolve into feeling, into the simple sense of something vast and calm. Somewhere above you, blue, and quiet, and always there. You are still here. And that is a wonderful thing. Your breath is slower now. Your body heavier. Your thoughts softer at the edges. We are going to keep moving gently through the sky. There is no hurry. No destination. Just this quiet voice. And the slow, careful unfolding of something true. Take one slow breath, and let it out even more slowly. Good. We have been learning about the sky as you know it. The sky from the ground. From a window, a garden, an open field. But tonight we are going to rise a little. Gently, slowly, in imagination only, and see what the sky looks like from higher up. You may have noticed, or perhaps heard someone mention, that the sky looks different from a mountain. If you have ever stood at a great height, Above the treeline, above the clouds, you might have felt something different about the blue above you. Something deeper. Something more serious. That feeling is real. And it has a reason. At higher altitudes, you are standing above a larger portion of the atmosphere. The thick, hazy, molecule-rich lower layers of air are now below your feet. Above you, there is less air. Fewer molecules. Fewer tiny scatterers doing their quiet work. And with fewer molecules above you, there is less of that diluting effect. Less of the other colors mixed into the blue. Less scattered red and yellow softening the hue. The result is a blue that feels purer, deeper, darker. On a high mountain peak, the sky overhead can look almost indigo. A rich, serious blue that feels somehow closer to space. Because it is closer to space. Just a few miles of thin cold air between you and the infinite dark above. Let that image settle. You, standing on something tall and still, beneath a sky so deeply blue it almost hums. And as you rise higher still, in our gentle imaginary ascent, the blue keeps deepening. Pilots of high-altitude aircraft, those who fly at the very edge of the atmosphere, describe looking up and seeing something extraordinary. Not the familiar soft blue of an afternoon sky, but a deep, electric, almost violet blue. So dark it begins to approach black at the very top. At those heights, 60 or 70,000 feet above the earth, the atmosphere above you is so thin, so sparse, that almost no scattering is happening overhead at all. You are seeing a sky that is running out of molecules, running out of the very things that make it blue. And the black of space, that absolute, infinite black, is beginning to show through. From that height you might see stars. Even during the day. Pinpoints of cold light. Visible because the scattered blue haze of the lower atmosphere is no longer thick enough to drown them out. Imagine that. Stars at midday. Visible only because you have risen above most of the blue. It is one of those things that quietly reminds you that the blue sky is not permanent, not inevitable, not infinite. It is a thin, precious, local thing. Now, here is something subtle and beautiful about where in the atmosphere the scattering happens most. You might assume that most of the blue light reaches you from the air closest to the ground, the air right around you. But that is not quite right. The upper layers of the atmosphere, the cooler, thinner regions high above, are actually where much of the efficient scattering occurs. This is partly because of the angles involved. Sunlight enters the atmosphere from above, and it is in those upper reaches that it first encounters air and begins to scatter, before it has been softened or diluted by the denser layers below. The blue that reaches your eyes from directly overhead has in many cases been scattered far above you, and then traveled down through the rest of the atmosphere to find you. The sky overhead is a kind of ceiling, but it is a ceiling made of events, each one happening miles above your head, in thin cold air, in silence. And there is a quality to that high-altitude blue, a coldness to it, that artists and photographers notice. The blue of a high clear sky, especially looking straight up, has what color scientists call a high color temperature. It leans toward the cooler end of the spectrum, towards something almost icy. It is different from the warm blues you might see near the horizon, or in late afternoon light. This overhead blue is clear, and cool, and still, like a glass of cold water on a quiet morning. And if you are ever lucky enough to be somewhere truly clean, somewhere far from cities and dust and haze, high in the mountains, or on a clear cold plateau, you might notice the sky takes on a very slight purplish cast. A blue so pure, so free of the softening haze, that the violet frequencies we talked about earlier begin to have a small voice again. They were always being scattered, but in dirty or hazy air. Other things drown them out. In perfectly clean air, they add just a whisper of violet to the blue, a barely there hint of something deeper. It is the sky at its most honest, unfiltered, undiluted, showing you as much of its true color as it possibly can. Now, all of this blue, depends entirely on one thing: the sun. Without the sun, there is no scattering. Without scattering, there is no blue. This seems obvious when you say it, but it is worth sitting with. A planet with no star, floating alone in the dark, could have an atmosphere full of nitrogen and oxygen, could have every molecule in exactly the right place, and its sky would be black. No light to scatter, no blue to find, just darkness and silence. The blue sky is not a property of air alone. It is a relationship between air and light, between the atmosphere and the sun. Remove either one, and the blue disappears. You experience this every night. When the sun sets and the sky darkens, the scattering does not stop completely. Not right away, but the light driving it, the bright white beam of the sun, is no longer reaching your part of the atmosphere. And without that light, the sky above you offers almost nothing. Just darkness, and stars shining through it. Points of direct light, unscattered, unchanged, having traveled for years or centuries to reach you exactly as they left their source. The blue is simply gone, waiting for morning. But there is one exception, one soft and ghostly exception, worth mentioning on a night like this. On nights when the moon is full, or nearly full, and the sky is clear, something faint and extraordinary happens. Moonlight is reflected sunlight. It is the same white light, the same spectrum, just dimmer, much dimmer, bounced off the gray surface of the moon and sent gently toward us. And when that moonlight passes through our atmosphere, it scatters, just as sunlight does, following the same rules, the same Rayleigh scattering, the same preference for shorter wavelengths. The result is a very faint, very pale blue sky. Not the deep vivid blue of noon, but a ghost of it. A whisper, barely there. On a clear full moon night, the sky between the stars is not pure black. It is the faintest imaginable blue. A blue so dim your eyes can barely register it as color at all. Photographers with long exposures can capture it. A pale cool blue haze between the pinpoints of starlight. The moon's quiet echo of the daytime sky. Some people call it the ghost blue. And that name feels right. It is the sky remembering what it does during the day. Practicing in the dark. At 1,000th of the brightness. Let that image rest with you. Outside right now. Even in the dark. Even in the night. The sky may be performing its quiet blue act. Very softly. Almost invisibly. And this brings us to something worth knowing. Something almost philosophical. In the gentlest possible way. The blue sky is what scientists call a diurnal phenomenon. Diurnal. Meaning it belongs to the day. It rises and fades with the sun. It is a sign. A living sign. That the sun is actively shining on your part of the atmosphere. Right now. When you step outside on a clear morning. And the sky is blue above you. What you are seeing is not just a color. You are seeing evidence. Evidence that the sun is up. That light is moving through your atmosphere. That photons are bouncing off molecules. Right now, this moment, above your head. The blue sky is the atmosphere showing its work. It is the sky saying, yes, the sun is here. Yes, the light is real. Yes, everything is continuing. Exactly as it should. There is deep comfort in that. The blue sky is a sign of continuation. Of the day arriving. Of the sun doing what it has always done. And tonight, as you lie here in the dark, the blue is resting too. Waiting for the sun to return. Waiting to scatter again. Waiting to fill the dome above you. With that familiar, faithful, quiet color. It will be there in the morning. You do not have to check. You do not have to wonder. It will simply be there. As it always is. As it has been for billions of years. Before there was anyone to look at it. And long after we are all quietly still. For now, let the darkness be enough. Let the ghost blue above you, faint and invisible and real, be a soft companion. You are resting beneath a sky that remembers how to be blue, and will be again, very soon. For now, just breathe, and let sleep come, gently, the way blue always does, slowly filling everything, from the top down, until there is nothing left but color and quiet, and rest. Still here, still with you. The night is quiet around you, and we have nowhere to be, nothing to do, nowhere to go. Just this, just the slow and easy telling of true things, about a sky you have known your whole life. Let your body feel the weight of the bed beneath you. Let your hands rest. Let your face soften. We have been traveling through the sky together, from the ground all the way up to the edge of space, and back down again. And tonight we are going to stay a little closer to Earth, closer to the horizon, closer to the edges of the day, where the sky does some of its most interesting and gentle work. Let us begin somewhere cold, and still, and very far away. Imagine the poles of the earth, those vast white places, where the land and the ice stretch endlessly, and the sun in winter barely rises at all. In the depths of polar winter, the sun does not climb high into the sky. It skims the horizon, or does not appear at all, sometimes for weeks at a time. And because the sun is so low, because its light must travel such a long shallow path, through so much atmosphere, the blue scattering we know so well is much, much weaker. The sky at the poles in winter, on the rare days when the sun appears, is not the deep clear blue of a summer noon. It is pale, washed, almost colorless, a blue so faint it is nearly white. The sun simply does not have enough height in the sky, enough directness, to drive the scattering the way it does at noon in summer. The blue needs the sun to be present, fully present, high and direct. And in polar winter, the sun is barely there at all. It is a humbling thought that the same sky, the same atmosphere, the same molecules can produce such different results, simply because of where the sun sits. The sky is not fixed. It is not one thing. It is responsive, always changing with the light that drives it. And speaking of change, the sky shifts throughout every single day, not just at sunrise and sunset, but continuously, in ways that are subtle and easy to miss. If you are not paying attention, when the sun is very low, just after rising, or just before setting, the sky behaves differently than it does at noon. The sunlight at those moments is traveling through the longest possible path of atmosphere. It enters at a shallow angle and must pass through far more air, far more molecules than midday light ever does. This changes everything. At sunrise, the sky is not yet fully blue. It is building, warming. The blue scattering is growing stronger as the sun climbs. But early in the morning the light is still weak, still traveling that long shallow path. And the sky has a softness to it, a paleness, a quietness that feels different from noon. The blue of early morning is a gentle blue, almost hesitant, as if the sky is not quite sure it is ready to begin. There is something very tender about morning sky. And as the sun rises higher, the path of light through the atmosphere shortens. The scattering becomes more efficient, more direct, and the blue deepens, reaches its peak around noon, and then very slowly, as the sun begins its afternoon descent, begins to soften again. Toward evening, the sky breathes. In the morning it is pale. At noon it is full. In the evening it begins to let go. Now, look toward the horizon on any clear day, and you will notice something. The blue fades. Not just a little, but quite a lot. Near the horizon, the sky turns pale. Almost white. Almost hazy. We touched on this before, when we talked about the gradient of the sky dome. But there is more to it. More worth knowing. Near the horizon, you are looking through the greatest possible depth of atmosphere, the longest path of air. And all of that air is doing something to the light. Blue light, scattered once, has a chance to be scattered again and again by all those extra molecules in the long horizontal path. When blue light is scattered multiple times, it loses its directionality. It spreads so broadly in so many directions that it begins to wash out, to thin, to become something more like white light than blue. All the colors blend back together. The way mixing too many paints eventually gives you gray. And so the horizon turns white, or pale gray, or faintly milky. Not because the blue is gone, but because it has been scattered so many times. It has lost its concentration. And there is something else happening near the horizon. Something slightly warmer. All that extra scattering at low angles does not just dilute the blue. It also lets the longer wavelengths through. The reds, and oranges, and yellows that usually lose out to blue. At the horizon, they have a better chance. They survive the long journey through all that air. And they add a slight warmth to the pale horizon haze. A very faint reddish quality. Barely there, but real. It is the same process that makes sunsets orange and red, just in a much milder, more subtle form. Happening all day long, right at the edge of the world. The horizon is always, slightly, gently, warmer than the sky above. A faint blush at the edge of everything. And you may have noticed, on days with distant mountains, or far-off cities, that the distant landscape looks blue. This is called aerial perspective. And it is the horizon haze at work. All that extra air between you and the distant hills scatters blue light into the space between, layering a soft blue veil over everything far away. Painters have used this for centuries, making backgrounds bluer and paler to suggest distance. Not because they invented the technique, but because they noticed what the sky was already doing. The world shows you its depth in blue. Everything nears its true color. Everything far away slowly fades toward the same pale horizon haze, as if distance itself has a color. And it does. That color is blue. Now, we have been talking about the calm and ordinary sky. The sky on a clear day. The sky that is predictable and quiet and beautiful. But the sky can also do stranger things. Rarer things. Things that only happen in unusual moments. On certain days, before a very powerful storm. The sky can briefly turn green. Not the full sky. Not a vivid or lasting green. But a strange, eerie, yellowish green. A color that feels wrong to anyone who sees it. Because it is wrong. Because it only happens when something unusual is in the air. Here is what causes it. Before a large thunderstorm. Or a tornado. The atmosphere is filled with water. Enormous amounts of water. In the form of thick, deep clouds and heavy, humid air. Water scatters light differently than air molecules do. And those deep storm clouds, often lit from below by the warm reddish light of late afternoon, can combine with the blue of the sky above. Blue and yellow make green. And in just the right conditions, with the right depth of cloud, the right time of day, the right angle of sunlight, the sky takes on that unsettling greenish cast. It does not last long. It is a brief, strange moment. A color the sky rarely wears. And people who have seen it describe it as one of the most memorable things they have ever noticed about the sky. Not beautiful exactly. More like significant. Like the sky is quietly announcing that something unusual is about to happen. The sky is a warning, written in an unexpected color. And then there is another rare sky color. One that happens above powerful storms. For a completely different reason. Above very intense thunderstorms. Especially large ones at sunset or twilight. The sky can turn a deep and vivid red. But not from the same cause as a normal red sunset. In this case, the storm itself is acting like a mountain. A vast, towering mountain of cloud. Pushing up into the atmosphere. Sometimes as high as 40 or 50,000 feet. And at those heights, above the storm, the setting sun can illuminate the tops of the clouds, painting them in brilliant orange and red, while the sky around them reflects that warm light, turning the whole horizon above the storm a deep and extraordinary crimson. It is one of the most dramatic things the sky ever does. And it happens precisely because of the collision between extreme weather below and the quiet physics of scattering above. Two completely different forces, producing one breathtaking color. Now, we have moved through many different skies tonight. The pale polar sky. The hesitant sky of early morning. The full and confident blue of noon. The whitened horizon. The blue veil over distant mountains. The eerie green before a storm. The red blaze above one. All of them are the same sky. The same atmosphere. The same molecules. The same ancient physics. Just light, arriving at different angles, at different times, under different conditions, and the sky responding, always responding, faithful and precise. The sky above you right now is doing none of these dramatic things. It is simply dark, and still, and quietly waiting for morning. But knowing all of this, knowing what the sky is capable of, what it has done today above you, and what it will do again tomorrow, makes the dark feel less empty. The sky is not absent tonight. It is resting, just like you, somewhere above the roof, above the clouds if there are any. The molecules are still there. The oxygen, the nitrogen, perfectly arranged, perfectly sized, ready for the sun to return, ready to scatter their blue, ready to paint the dome again. At dawn, you do not have to wait for it. You do not have to watch. Just trust that it will happen, just as it always has. And let that trust carry you deeper into the quiet, deeper into the dark, deeper into the long and restful nothing of a night passing slowly, gently, toward morning, still with you, still here, in the quiet. There is no hurry. There never was. Let yourself sink a little deeper into wherever you are resting. Feel the stillness of the room around you, the soft weight of the dark. We have covered so much sky together, and there is still more. Gentle things, things that connect what we already know to new and quiet corners of the same story. Tonight we are going to find those connections, slowly, one at a time, like turning pages in a book you never want to end. We have talked about Rayleigh scattering many times now. That beautiful invisible process, where tiny molecules redirect blue light in all directions, filling the dome above you with color. But here is something worth holding for a moment. Rayleigh scattering does not just explain the blue sky. It explains red sunsets too. The same rule, the same physics, the same preference for short wavelengths produces both of these things. At noon, when the sun is high, its light travels a short path through the atmosphere. Blue is scattered efficiently, and it fills the sky. But at sunset, when the sun is at the horizon, its light must travel an enormously longer path, through far more atmosphere. By the time that light reaches you, the blue has been scattered away completely. Scattered so many times, in so many directions, that almost none of it makes it through to your eyes. What remains, what survives that long journey, is the light with the longest wavelengths, the light that is hardest to scatter. Red and orange and deep gold. The same process that pulls blue out of the sky at noon pulls everything else out at sunset, leaving only red behind. One rule, one elegant rule, and it paints the sky two completely different colors, depending only on the time of day. depending only on how far the light has traveled. That kind of simplicity, underneath such obvious beauty, is one of the most restful things physics ever offers us. One rule: infinite skies. Now, between the day and the night, there is a brief and beautiful window. A time that photographers and painters have always loved. It is called the blue hour. It happens just after sunset, or just before sunrise, when the sun has dipped below the horizon, but its light still reaches the upper atmosphere. At that moment, the sky does something unusual. The direct warm light of the sun, the oranges and reds of sunset, have faded. But high above, the atmosphere is still being illuminated, still scattering, still working. And what it scatters at that angle, from that geometry, is a soft and deeply saturated blue. A blue quite different from the midday sky. Cooler, darker, more violet, spreading across the whole sky. For just a few minutes, the blue hour is the sky at its most melancholy, its most tender, the color of the world holding its breath between day and night. It does not last. It never does. But while it is there, it is one of the most quietly beautiful things the atmosphere can offer. And now you know what makes it. The same Rayleigh scattering. The same molecules, just catching the last edge of sunlight from a geometry that briefly, perfectly, intensifies the blue. Let that image rest with you. That soft deep blue between day and dark. Now, there is another ingredient in the sky. One we have not mentioned yet. One that quietly adds its own contribution to the color above you. Ozone. High in the atmosphere, in a layer mostly between 15 and 35 kilometers up, there is a thin but important concentration of ozone molecules. Ozone is a form of oxygen. 3 oxygen atoms bound together, instead of the usual 2. And ozone has a particular relationship with light. It absorbs certain wavelengths very strongly, particularly in the red and orange end of the spectrum. When sunlight passes through the ozone layer, some of its red and orange is quietly, selectively, removed, absorbed by those ozone molecules before it ever reaches the lower atmosphere. This means the light that goes on to be scattered by the lower atmosphere is already slightly bluer than raw sunlight would be, slightly shifted toward the shorter wavelengths. Ozone is quietly tilting the game, giving blue an even greater advantage, adding its own subtle contribution to the color of the sky. On days and in places where ozone concentration is higher, the sky can appear fractionally more blue, more saturated. The ozone layer is like a silent partner to Rayleigh scattering, working above it, preparing the light before the real scattering begins. And the total amount of ozone above you at any moment, what scientists call total column ozone, varies depending on where you are, what season it is, and conditions in the upper atmosphere. So even ozone plays a part in what your sky looks like today, versus what someone else's sky looks like. On the other side of the world, the sky is never exactly the same twice. Not truly. Now, we have been talking about a clean atmosphere, clear air, nothing but oxygen and nitrogen and a little ozone. But the real atmosphere is rarely quite that pure. The air carries things: dust, sea salt, pollen, smoke, and in many places, pollution, particles of soot and haze from engines and fires and factories. These particles are larger than molecules. Much larger. Large enough that they scatter light differently. Not following Rayleigh's elegant rule, but following a different process entirely. This different process is called Mie scattering, named after the physicist Gustav Mie, who described it in the early 20th century, where Rayleigh scattering strongly prefers blue. Mie scattering is far less selective. It scatters all wavelengths much more equally. All colors, scattered together. The result, when Mie scattering dominates, is not blue. It is white, or gray, or a milky haze that softens everything. On a hazy day in a city, or near a dusty desert, or downwind of a fire, the sky loses its deep clean blue and takes on that whitish quality, as Mie scattering from larger particles competes with and begins to overwhelm the pure blue of Rayleigh scattering. The two processes are always happening together, always in competition. Rayleigh pulling toward blue, Mie pulling toward white, and the balance between them determines the quality of the sky on any given day. A deep clean blue sky is a sky where Rayleigh is winning, where the air is clear enough, pure enough, small particled enough for the blue to dominate. A hazy whitish sky is a sky where Mie is making its presence felt, where something larger has entered the air, and the blue is paying the price. And this brings us to clouds. Those great soft white things that are made of water droplets, each one enormously larger than an air molecule. Water droplets scatter light entirely through Mie scattering, and they scatter all wavelengths almost equally. Red, orange, yellow, green, blue. All of it, together. And all colors of light, mixed together, make white. This is why clouds are white. Not because they block the light, but because they scatter it equally. Without preference. Without the elegance of Rayleigh. Just a broad and democratic scattering of everything at once into white. The whiteness of clouds is the absence of preference, while the blue of the sky is the presence of it. On a day with thick clouds, the sky behind and within them is not blue. The blue scattering is still happening in the clear air, but the clouds scatter and diffuse so much light that the blue is overwhelmed, lost in the general whiteness. You know this feeling. The flat pale light of an overcast day. The sky a uniform gray-white. The blue simply absent, waiting behind the clouds, waiting for them to part. The blue is still there, but quieted, muffled, like a sound heard through a closed door. And then there is humidity, that quality of the air on warm, wet days, when the atmosphere feels heavy and soft. Water vapor is present in all air, but on humid days it is everywhere. And while individual water vapor molecules are small, on very humid days the air begins to carry tiny clusters, microdroplets, just on the edge of forming into something larger. These clusters are large enough to contribute a little mia scattering. Not enough to make the sky white, not enough to make clouds, but enough to soften the edges of the blue, enough to reduce the saturation just slightly. On a very humid summer day, even with a clear sky, the blue is not quite as pure, not quite as deep, as it would be on a crisp, dry autumn afternoon. The humidity breathes into the blue, softens it, the way breath fogs a cold window, not erasing it, just blurring it gently. And so the quality of the sky's blue is a report, a quiet daily report, on the state of the air above you. A deep saturated blue means dry, clean air. Rayleigh scattering working at its best. Ozone doing its part. Nothing large enough to compete. A paler, softer blue means moisture, or haze, or particles. Something in the air adding its voice, diluting the pure signal. The sky is always telling you something, if you know how to listen. And now, you do know. You have all of this quietly inside you now. Rayleigh and Mia. Ozone and humidity. Clean air and hazy air. White clouds and blue gaps. All of it connected. All of it part of one continuous, breathing, responsive system. Above your head. Every moment of every day. The sky is not a backdrop. It is not wallpaper. It is a living report on the state of the atmosphere. Written in color. Updated constantly. Available to anyone who looks up. And tonight, you do not have to look up. You can simply know it is there, doing its quiet work, reporting faithfully, to no one in particular, just because that is what it does. Let that feel like a kind of companionship. The sky continuing above you, even as you rest, even as you stop paying attention, faithful and unhurried. Your breath is slow now. Your body is heavy and still. The room around you is quiet. The air above your roof is full of molecules, each one perfectly sized, each one ready, waiting for the sun. And you are here, warm and drifting, and everything is exactly as it should be. Still here, still breathing, still resting in the quiet. The night holds you gently, and we are going to stay here together a little longer. There is something deeply peaceful about learning slow and gentle things in the dark. Things that ask nothing of you. Things that simply are. Let your shoulders fall. Let your jaw unclench. Let your hands rest open. Tonight we are going to think about the sky and everything that touches it. Everything that moves through it. Everything that changes it. From far above and close below. We know now that the cleaner the air, the bluer the sky. We know that molecules and particles each play their part, each pull the color in their direction. But there are forces that reach into the sky from unexpected places and leave their quiet mark on the color above us. Let us begin very high up, at the very edge of the stratosphere, where the air is thin and cold, and mostly undisturbed. There is dust up there. Not the dust of a dirty floor or a dry road, but a faint and ancient kind of dust. Microscopic particles that drift in the upper atmosphere, some of them having traveled extraordinary distances, carried up by weather systems and winds, from deserts and dry plains, from the surfaces of continents. These particles are tiny, but they are present, and they scatter light in their own quiet way, adding a faint, barely perceptible tint to the upper sky. On most days you would never notice. The effect is too subtle, too easily drowned out by everything else. But on certain days, when upper atmosphere dust is particularly dense, the sky can take on a quality that is hard to name. A slight milkiness at great heights. A faint softening of the deepest blue. As if someone has breathed on the very top of the sky. Very gently. It is one of those things that rewards attention. The kind of thing you only see if you have been watching the sky for a long time, with patient and unhurried eyes. And then there are volcanoes. When a large volcano erupts, it does not just throw ash and rock into the local air. The most powerful eruptions send material all the way into the stratosphere. 15, 20, sometimes 30 kilometers up. Up there, above the weather, above the rain that would normally wash particles back down. Those tiny droplets of sulfuric acid and fine ash can stay suspended for months, sometimes for years, drifting slowly around the entire planet, carried by high-altitude winds. And while they are up there, they scatter light. In their own way, they add a new layer to the sky's optical behavior, sometimes making sunsets more vivid, more orange and red and purple, as their extra scattering enriches the colors at the horizon. But they also soften the blue. The midday sky in the year or two after a major eruption can be subtly different, slightly paler, slightly more veiled, as that stratospheric layer quietly interferes with the clean blue Rayleigh scattering below. Some of the most extraordinary sunsets in recorded history, the ones that painters and poets noticed and wrote about, were the gift of volcanic eruptions, happening on the other side of the world. Months before, the sky carrying the memory of fire. In color. Let that sit quietly for a moment. Now let us come back down. Closer to the ground. Closer to where most of us spend our lives. In cities. The sky is different. Not dramatically different. Not so different that most people stop and notice. But different in ways that are real. And measurable. And worth knowing. Urban air carries things. Exhaust from vehicles. Particles from construction. Industrial haze. The accumulated breath of millions of people and machines. All of it adding larger particles to the air. All of it introducing the scattering. All of it competing with the blue. The result is what people sometimes call a washed-out sky. A sky that is technically blue, but lacks the depth and saturation of a sky over open countryside or clean ocean air. The blue is there, but it has been diluted, thinned by all that extra scattering, softened at the edges, pulled toward white. People who move from cities to the countryside often comment on the sky, on how blue it is, on how different it feels. And they are right. They are not imagining it. The physics is genuinely different. In thick urban haze, the sky is also slightly dimmer. Not just paler in color, but actually carrying less light to your eyes. The haze absorbs some of what it scatters, taking a little of the brightness for itself, leaving the sky quieter than it would otherwise be. And this changes with the seasons. In summer, in many parts of the world, the air carries more moisture, more biological particles, more of the fine haze that builds up in warm, still conditions. And the sky, while still beautiful, is often softer and paler than the same sky in winter. Winter skies in cold, dry climates are often the bluest of all. The cold air holds less moisture. The particles have been washed or frozen out, and Rayleigh scattering has the stage almost to itself. There is a reason that winter blue feels different. Feels almost electric. Feels like it has more depth to it. It does. The seasons write themselves into the sky's color. Summer softening it. Winter sharpening it. Spring and autumn somewhere in between. The sky is a calendar, as much as a color. Now, we have talked about what changes the blue, but let us take a moment to appreciate what enables it. All of the scattering, all of the blue, all of the beauty we have been describing, depends on one fundamental thing: sunlight actually reaching the molecules. This sounds obvious, but it is worth sitting with. The blue of the sky is not stored. It does not accumulate. It does not carry over from one moment to the next. Every single photon of blue light you see was scattered just now, moments before it reached your eyes. The sky is not a painting that was made once. It is a performance, happening continuously. requiring the sun's constant input, requiring light to be present and moving. Every moment. If the sunlight dimmed, the blue would dim with it. Instantly, faithfully, with no delay. The sky's blue is as fresh, as immediate, as this breath you are taking now. And when rain comes and washes the air, scrubbing the particles from the atmosphere, pulling the dust and haze down to the ground, leaving the air clean and rinsed and new, the sky that follows, the sky after rain, is often the most beautiful blue of all. You have felt this, even if you never had words for it. That particular quality of the sky after a storm passes. When the clouds break, and the blue that appears is so vivid, so saturated, so clean, that it almost feels unreal. It is not unreal. It is simply the sky at its most honest, with everything that usually softens it washed away. Rayleigh scattering, working in air so clean that almost nothing competes with it. The blue after rain is a gift. The atmosphere thanking you for your patience, with the purest color it can offer. And that cleanness, that clarity, is also a sign of something larger, something meteorological. A deep blue sky is not just beautiful. It is a sign of stable air, of what meteorologists call a high-pressure system, a region where the air is sinking gently, compressing, clearing, pushing haze and particles downward and outward, leaving clean dry air in its place. The blue sky tells you the atmosphere is settled, organized, calm. It is the sky in a quiet mood, a peaceful mood, a mood that matches the one you are in right now. Still, settled, clear. And finally, there is one more delicate thing worth knowing before we let this section rest. Temperature. The sky's blue is faintly, subtly sensitive to the temperature of the air. Not dramatically. The difference is small enough that you would never see it with your eyes alone. But it is real. Temperature affects the density of the air. Warm air expands, becomes less dense, fewer molecules per cubic meter. And with fewer molecules in any given volume of air, there is slightly less Rayleigh scattering, slightly less blue being redirected toward your eyes. Cold air is denser, more molecules packed into the same space, more scattering, more blue. This is another reason why cold, clear winter days produce such extraordinary blue skies. Not just the dryness, not just the lack of haze, but the density of the cold air itself. More molecules doing their quiet work, producing more blue per cubic meter than warm summer air ever could. The sky in winter is not just cleaner. It is fuller, more packed with the very things that make blue possible. And you carry all of this now. This long and layered understanding of everything that touches the sky. volcanoes sending their material into the stratosphere, cities breathing their haze into the lower air, rain washing everything clean again, cold air densening, stable air clearing, the sun providing its constant indispensable light, all of it meeting, all of it combining into the specific blue of this sky, above this place. On this day, no two skies are truly identical. Every day's blue is its own, shaped by everything the atmosphere has been through, everything it is carrying, everything the sun has given it. And yet, every blue sky is recognizably, unmistakably, the same Rayleigh scattering, the same preference for blue, the same dome overhead, the same faithful physics. Underneath all the variation, underneath all the change, something constant. In all the flux, let that feel like something solid, something to rest against. The world changes, the air changes, the seasons change, but the blue, the deep quiet reason for the blue, stays exactly the same, has always stayed the same, will always stay the same. And so will you. Resting here, breathing slowly, held by something constant and quiet. Let the night continue. Let sleep deepen. Let everything go still. Still here. Still with you. In the gentle dark. You have been resting for a while now, and the night is deep and soft around you. There is no need to hold on to anything, no need to remember, no need to follow closely. Just let the words arrive and pass through you like a slow and quiet current. Breathe in and out. Good. We are going to wander a little tonight. A little further than usual. Past the sky. Past the atmosphere. Out toward the stars. And then gently back again. To the water. To the ocean. To the soft blue world. But we begin, as we often do, with the air. We have talked about how clean air makes the bluest skies, how rain washes everything clear, how cold dense air scatters more blue than warm thin air. But there is a small and quiet paradox here, worth turning over gently before we move on. Very dry air. Air with almost no moisture at all, is in some ways less blue than you might expect. This seems strange at first. We said humidity softens the blue, so surely removing humidity would deepen it. And in most cases that is true. But in air that is extremely dry. So dry it occurs mainly in high deserts, or in certain cold arid regions. The air can lack even the faintest trace of the tiny clusters, the microparticles, that in normal humid air actually contribute a small amount of scattering. In that extreme dryness, the scattering is technically pure, but also very slightly reduced in total. The sky in very dry air can have a quality that is hard to describe. A crispness, a hardness almost. A blue that is clean but somehow thin. Not soft. Not rich. But precise. Like a line drawn very carefully. With nothing extra. It is a beautiful kind of blue in its own way. Just a different blue. A blue without warmth. Without depth. A blue that knows it is alone. And speaking of alone, let us think for a moment about the places on Earth where the sky sees the least of the sun. At high latitudes, far from the equator, the sun travels low across the sky, even at its highest point in summer, and in winter barely rises at all. This matters for the blue, because the lower the sun, the longer its light travels through the atmosphere, and the more of everything gets scattered and diluted. Not just blue, but all the colors, mixed and spread, until the sky takes on that paler, more washed quality we talked about near the horizon, but now happening across the whole sky, throughout much of the day, at high latitudes, in places like northern Scandinavia, or the far reaches of Canada or Russia. The sky is often a softer blue, less saturated, more gentle, as if the light has traveled so far to get there, that it arrives a little tired, a little diffused. And in the polar regions themselves, where the sun is absent for months, or present only as a long low slant of light, the sky can appear almost white, a pale and luminous white blue, that feels more like ice than sky. It is beautiful in its own way, austere and still, the kind of beauty that asks you to be very quiet, very present. The polar sky does not shout. It whispers. Now compare that to the equatorial sky, to the sky directly over the tropics. On a clear, dry day, there, the sun climbs almost directly overhead, its light traveling the shortest possible path through the atmosphere, encountering the minimum of extra scattering and dilution, arriving at the scattering molecules with maximum intensity, maximum purity, and the result is a blue that people who have stood under it often struggle to describe. A blue that seems almost too blue, impossibly saturated, deep and bright at the same time. The kind of blue that makes you stop and simply look for a long moment, without words. The equatorial sky is the blue sky at its most confident, its most fully realized, as if the atmosphere is showing you exactly what it can do when given perfect conditions. Now, let us leave the sky for a moment. Let us drift upward, past the atmosphere, into the dark and quiet of space, where the stars wait, as they always do, in their patient and ancient places. Here is something that might gently surprise you. The same physics that makes the sky blue, the same Rayleigh scattering, is also responsible for something you see on clear nights. Stars twinkle. You have seen this your whole life. That slight shimmering, That gentle flickering of starlight, as if the stars are breathing or blinking very slowly. It happens because starlight must pass through our atmosphere, through all those layers of air, with their different temperatures, different densities, constantly moving, constantly shifting. As the light passes through these shifting layers, it is bent and redirected, slightly, continuously, the path of the light wavering just a little, as the air moves between the star and your eye, and scattered, just as sunlight is scattered, by the same molecules, following the same rules. The twinkling of stars is Rayleigh scattering, made visible in a different way, not as a color, but as a movement, a shimmer, a soft and continuous flickering. The atmosphere cannot hold the starlight still. It touches it, bends it, redirects it, and the star appears to dance. Every star you have ever watched twinkle was doing so because of the same process. That fills your daytime sky with blue. 1 physics, 2 effects, separated by the difference between day and night. And there is more. When you look at stars on a very clear night, and you look carefully, you may notice that they are not all the same color. Some stars are distinctly blue-white, cold and sharp. Others are warmer, more yellow. Some are distinctly orange, or even red. These colors tell you something real about the stars themselves, about their surface temperatures, their ages, their natures. But to reach you, those colors must pass through the atmosphere, and the atmosphere treats them just as it treats sunlight, scattering the shorter wavelengths more, subtly shifting the colors toward the red end. For stars near the horizon, where the light path through the air is longest, a blue star seen directly overhead, where the atmosphere is thinnest, will appear truer to its actual color than the same star seen near the horizon, where its light has been filtered and reddened by all that extra air. The atmosphere colors the stars, as it colors the sun, as it colors everything. And in space, above all that air, the stars show their true colors, unmuted, unfiltered, honest. Astronomers who study stars from space see a sky full of colored lights, each one a slightly different hue, telling its own story. In pure unscattered light, it is a different sky up there, older, truer, but colder, and somehow less comforting than our blue one. Now, let us come gently back down, through the atmosphere, back to the surface of the earth, to the ocean. You may have wondered, lying here, whether the ocean is blue for the same reason the sky is blue. It is a fair question, and the answer is almost, but not quite. The ocean is blue partly because it reflects the sky above it. On a clear day, The surface of the sea mirrors the blue dome overhead and takes on its color. But even deep water, even water in a dark room, even water with no sky to reflect, has a faint blue quality. This is because water itself absorbs light, and it does not absorb all wavelengths equally. It absorbs red and orange more readily than blue. So when white light enters deep water, the reds are slowly consumed. The oranges fade. And what remains, what survives the depth, is blue. The ocean makes its own blue, independent of the sky, through absorption rather than scattering, through a completely different physical mechanism, arriving at the same color, by a different road. And here is the gentle connection. The ocean and the sky, each blue for their own reasons, each following their own physics, each arriving at the same quiet color, together cover most of what you can see when you stand on this planet. Look up, blue. Look out to sea, blue. No wonder blue feels like the color of the world. No wonder it feels ancient, and deep, and calm. It is everywhere, above and around, made by different processes, but singing the same note. And the ocean does contribute something to the sky, in its own small way. Seawater evaporates, and tiny salt particles rise into the air above the ocean. Microscopic crystals, drifting on sea breezes, carried inland. These sea salt particles are larger than air molecules, and they scatter light through scattering, adding a slight softness, a coastal haze, to the sky above the shore. The ocean breathes itself into the sky, and the sky carries a little of the ocean salt, wherever the wind takes it. The two blues are not entirely separate. They touch. They exchange. They share. Everything connects. In the end, everything in the atmosphere and on the surface of the earth touches everything else. Slowly, quietly, over time. The sky and the sea, the poles and the equator, the stars and the scattering, the twinkling and the blue. One physics, one set of rules, expressing itself everywhere, in every direction, in every color of the sky, at every hour of every day. And you have been holding all of this, gently, without effort, letting it drift through you like something slow and warm. You do not need to hold it tightly. You do not need to remember every part. Just let it settle, like sediment in still water, sinking slowly, quietly, to the bottom. The stars are above you tonight, twinkling through the atmosphere, the same atmosphere that gives you blue by day. The ocean is somewhere in the world, making its own blue, absorbing its reds, reflecting the sky it lives beneath. And you are here, in the still and quiet dark, beneath all of it, warm and heavy and held Let the night deepen around you. Let your thoughts thin out, like morning mist, quietly, without effort. Just breathe and rest. Still here, still resting, still breathing slowly in the quiet. You have come a long way tonight, through the atmosphere, up to the edge of space, out to the stars, and back down to the sea. And now we are going to do something a little different. We are going to step back, very gently, and look at the blue sky, not just as something above you, but as something rare, and specific, and quietly extraordinary. Let your body settle a little more. Let your thoughts grow softer. The blue sky is a molecular color. This is worth sitting with. When you look up at a clear sky, you are not seeing clouds. You are not seeing water. You are not seeing any surface or substance you can touch or hold or point to. You are seeing the color of individual molecules, the collective optical behavior of particles so small they make dust look enormous. The blue of the sky is not painted onto anything. It is not reflected from anything. It is made continuously by the interaction of light and matter. At the most fundamental level, no surface required, no pigment, no dye, just molecules, and light, and physics. This makes the skies blue unlike almost any other color you encounter. The blue of a painted wall is pigment absorbing light. The blue of water is absorption and reflection. The blue of a butterfly wing is microscopic structure. But the blue of the sky is something purer. A color that arises from almost nothing. From the interaction of a wave of light with something too small to see. It is perhaps the most fundamental color in nature. The color that emerges when light meets air. When a star shines through a clear atmosphere. Let that feel remarkable. And yet, for all its vividness, for all its presence in our lives, the blue sky is surprisingly quiet. About the other colors, we know that blue dominates the scattered light. But the sky contains traces of every color. Red, orange, yellow, green. All scattered to some degree. All present in the light that reaches your eyes from every direction. If you could take that skylight and pass it through a prism, you would see a faint rainbow. Not just blue, but all the colors. Blue simply louder than the rest. The sky is a chord, not a single note. Blue is the dominant note. The one your ear, your eye, picks out above the others. But the others are there, humming quietly underneath. The sky is richer than it appears. More complex. More layered. And now, a thought that is gentle and a little strange, and worth carrying into sleep. We gave the sky its name. Humans named it, looked up, and called it sky, or Himmel, or Ciel, or Cielo, or 1,000 names in 1,000 languages. all pointing at the same blue thing. But the sky did not know it was blue until we said so. The sky has no experience of itself, no awareness of its own color. It simply scatters. And the blue exists only because there are eyes to receive it, minds to register it, words to name it. The blueness of the sky, in some quiet philosophical sense, is a collaboration between the physics of light and the biology of sight, and the human need to name what we see. Take away the eyes, and the scattering still happens. But the blue, as we know it, as a color, as an experience, exists only here, inside you. That is a thought worth resting on. For just a moment. The sky is blue because you are here to see it. Now let us travel one more time, away from Earth, out into the solar system, and then to other stars, other planets, other skies. Our sky is blue because of two things working together: the Rayleigh scattering of our atmosphere, and the particular color of our sun. Our sun is what astronomers call a G-type star, a yellow dwarf. Its surface burns at about 5,500 degrees, and it emits light across a broad spectrum, with a peak somewhere in the green-yellow range, but plenty of blue and red on either side. This particular spectrum, this particular distribution of light, combined with our particular atmosphere, produces the particular blue we know. Change the sun, and you change the sky. Imagine a planet orbiting a red star, a cooler star, one that emits far less blue light to begin with. Even with the same atmosphere, even with the same Rayleigh scattering, there would be so little blue in the incoming light that the sky might look yellowish, or pale orange, or a deep reddish haze. And a planet orbiting a very hot blue-white star, a star much hotter than our sun, flooding its system with intense ultraviolet and blue light, might have a sky of deep violet, or white blue so intense it would hurt to look at. The color of the sky is not just a property of the atmosphere. It is a property of the star, filtered and processed by the atmosphere, a collaboration between a sun and its air. On Mars, the sky is not blue. Mars has a thin atmosphere, made mostly of carbon dioxide, with a great deal of fine red dust suspended in it. That dust scatters light in its own way, giving the Martian sky a pale pinkish butterscotch color during the day, and near sunset, a strange blue-gray glow near the sun, the opposite of what we see on Earth, where sunsets are warm and the midday sky is blue. On Mars, the midday sky is pale and warm, and the sunsets carry a ghostly blue. The same physics, completely different result. Because the atmosphere is different. Because the dust is different. Because the sun appears smaller and cooler from that greater distance. Every planet with an atmosphere has its own sky, its own color, its own version of what we experience every day without thinking. And all of them, every alien sky on every distant world, follows the same rules. Rayleigh scattering, Mie scattering, the same equations, the same physics, applied to different ingredients, producing different colors. The universe knows only one way to make a sky, and it applies that method everywhere. Now, here is something quietly practical, and then something quietly profound. To close this section, the blue of a clear sky, because it is so consistent, so predictable, so governed by known physics, is actually used as a reference, a calibration tool, by photographers and camera engineers when designing a camera, or calibrating a sensor, or testing whether colors are being reproduced accurately. A clear blue sky on a clean day is one of the most reliable natural references available. Not a painted chip, not a laboratory standard, but the sky itself. Because the sky is so stable, so reproducible, so well understood, that it serves as a living standard for what true color looks like. The sky that you look at and simply call beautiful is precise enough, consistent enough, to be used as a scientific instrument. It is both art and measurement, both wonder and reference, both the oldest thing you have ever seen, and one of the most reliable. And this brings us to the last thought for tonight, the one I want to leave you with. As your eyes grow heavy, and the words begin to dissolve into the comfortable dark, the blue sky is the default. Not default in the sense of ordinary or unimportant, but default in the sense of foundational. Given a planet with a clear atmosphere made of small molecules and a star shining the right kind of light, the sky will be blue, not red, not green, not white. Blue. This is the baseline, the starting point, the color the universe reaches for when the conditions are right. Our blue sky is not an accident of our particular planet. It is what happens naturally when light and clear air meet, when the physics is allowed to do its work undisturbed. It is the universe's resting color, the color of a clear and quiet day, on any world, around any star, where the conditions allow it, and we live beneath it. Every day, often without a second thought, we walk under the universe's default color. We eat our lunches beneath it. We drive through it. We glance up at it briefly and return to our days, not knowing that above us, the atmosphere is performing one of the most elegant acts in nature. But now you know. You carry all of this quietly now. The molecules and the wavelengths, the scattering and the gradients, the polar skies and the equatorial skies, the alien skies of other worlds, the calibration tools and the collaborations, the philosophy of color and naming. All of it. Resting gently inside you. Like sediment in still water. Settled and quiet. Asking nothing. The sky will be blue again tomorrow. The default restored. The baseline reestablished. The same physics. The same beautiful result. That is greeted every morning. On this planet. For billions of years. And you will be there to see it. Rested. And warm. And knowing just a little more. About why. But that is tomorrow. Tonight. The sky is dark. And quiet. And the molecules are waiting. And you are here. Drifting. Slowly. Through the soft and comfortable nothing. Of a deep and restful sleep. Let go of the last thought. Whatever it is. Just let it go. The blue will be there in the morning. It always is. And so will you. Good night.